In this video, we're going to be looking at the least squares regression line. So we are moving on now in your Unit 4 booklets to page 23. If you can make sure you're in the right place, please. As always, I'm going to go through the specification objectives just to make sure you can see what the exam board are expecting of you. So you need to be able to understand the properties of the least squares regression line. So that might be something you haven't heard of before. You need to be able to use a calculator to determine the equation of the least squares regression line. You need to be able to make predictions using the equation of the least squares regression line. You need to be able to use interpolation or extrapolation arguments to comment on the reliability of these predictions. You need to be able to understand a definition of a residual. You need to be able to identify outliers as values with large residuals, and you need to suggest possible explanations for outliers. So obviously we've already done some work on interpolation and extrapolation, so we should be able to just follow that through into this topic. And we've also done some work on outliers, so you should have a good idea of what those are. So it's just now using this new term residual to help us. So looking then on page 23. So the least squares regression line. The whole booklet that we're looking at the moment, the whole of Unit 4, is bivariate data. And we've looked at bivariate meaning two variables. When we have our two variables, we need to be able to determine which one is the explanatory and which one is the response variable. So we've looked at, when we started this topic, independent and dependent variables, and we've said sometimes if there is a correlation but no causality, we don't necessarily have an independent and dependent variable, and that's not always the case. However, we should always have an explanatory and a response variable, even if they are correlated without causality. So the explanatory variable is the one that you are in control of, the one that you can change. It's the one that is the experiment. So it's the one that you are doing, the one that you are, even if it's something that you're measuring, it's something that you're measuring at specific points that you have chosen. It's normally the one that comes first in your data set, so either the top of the table or the left-hand side of the table. It's the one that goes on the x-axis. So the response variable is the one that you measure after you've manipulated, you've adapted, you've changed your explanatory variable. So it's the one where after you've done something, you see what happens. It usually comes second on the table, so at the bottom row or the right-hand side, and it goes on the y-axis. It's plotted on the y-axis. So there's a couple of examples that I just want to talk through with you, and we're going to be able to see if we can find the explanatory and the response variable. So still on page 23. So example A, it says data is collected on the age of used cars and the price that they sell for at auction. Which from the data collected in the investigation is the explanatory variable? So out of the two things, you obviously aren't necessarily in control of either of those things. You can't control how old the car is. You can't control how much it sells for at auction. But you've got to think about which one is going to potentially cause the other one to happen. Which one's more likely to be the independent variable or the dependent variable? So out of these two things, I think about the age of a car and I'm thinking about this, how much it costs at auction. And I think the one that I have control over, the one that I can measure at certain points, is the age of a car. I can choose a car that is 10 years old. I can choose a car that is 9, 8, 7, 6, 5, 4, 3, 2, 1 years old. And then I can see what happens. I can see what the response is at the auction. So the explanatory variable in this question would be the age of the used car or the used car. And then in turn, that means that the response variable would be the price sold at auction. So hopefully you can see from that sort of questions, from the context, that the one that explains the price is the age of the car. Example B. the age at which employees join the company is correlated to the starting wage of each employee. Which of these two variables is the response variable? So again, I need to think of my two variables. So I've got an age of an employee and I've got their starting wage. And again, I need to sort of think in my head which one explains the other one. It said there is a correlation. It doesn't tell me if it's positive or negative. But I know that they are correlated in some way. And I need to start to think now about which one might predict the answer to the other one. So similar to the previous example, I'm going to think which one can I look at, which one can I have a bit more control over to then see what the answer would be. So I have control at looking at what age people start. So I can see, oh, I've got somebody who started at 18, somebody who started at 24, somebody who started at 25, and somebody who started at 30. So that will be my explanatory variable, and therefore my response variable, which is what it's asking for, would be what their starting wage was. On page 23, if you can just make sure, please, that you have got those two examples written down. You might want to just pause the video here so that you can do that. Okay, so what I would like you to do, please, is I would like you to have a go at exercise 4.3a, which is at the bottom of page 23. There's only 6 questions, but if you can have a go at doing those for me, please. For each one, you need to identify the explanatory and the response variable. Okay, so pause the video here, have a go at those questions. All the answers are on the PowerPoint that is also on Teams. So once you've done those, if you can check your answers and just make sure you're getting those right and you're identifying the explanatory and the response variable properly. Okay, I'm going to end the video here, and the next video is how to find the equation of the least squares regression line. You need to do that once you've checked your answers.